distribution of the response variable employment status by level of education, So we want the proportion of employed for each level of education, not looking at any of those. 9,699 divided by the total of this level. 1,049 divided by the total of the level, and so on and so forth. So of course, when I divide the 25,644 by 25,644, I would get 1. So now the probability that I'm looking for is 9,699 divided by the total. 9,699 divided by 25,644. And that gives us a probability of, or proportion if you like, of 0.378. The next one, 1049 divided by 25,644, and I got a probability of 0.041. 15896 divided by 25,644. And you'll see in a moment what we conclude from this. 0.581. The sum has to be 1. If it's not 1, I have to make some adjustments. 0.378 plus 0.041 plus 0.581. Okay, perfect. Moving on. 33677 over the total, and so on and so forth. And this, when I add them up, I have to get 1 for all of them. If not, I have to make some adjustments. 33677 divided by 62486. I got for this 0.540. And next one, 2565 divided by 62486. And correct my numbers always. 41 26244 divided by 62486. And I got 0.42. Again, I have to make sure that they add up to 1. 0.50 plus 0.0541 plus 0.42. Okay, so I do have a tiny 1, so I'm going to have to change either this into 39 or this into 40. So I'll change this into 39. They have to add up to 1. 0.539 plus 0.041 plus 0.42. The sum has to be 1. Okay, so maybe I should have not rounded up that one. Okay, next one. 34750 divided by 54766. And I got 0.63, maybe 5. We'll see in a moment. If not, I'll go back. 2272 divided by 54766. And I got 0.041. This is so consistent, as you see. And 17744 divided by, nope, too many 4s. 17744 divided by 54766. And this is 0.324. Again, we'll see in a moment. 0.635 plus 0.041 plus 0.324. It's 1. Perfect. Last one. 48134 divided by 66081. It appears that this is 0.728. 1625 divided by 66081. Okay, this appears to be 0.025. We'll see in a moment. 16322 finally divided by 66081. And 0.2, maybe 247. Yes, 0.728 plus 0.025 and plus 0.247. If it's not 1, it is 1, so it's okay. Okay, so now let's answer the question. What is the association between level of education and employment status? So let's take a look. For those who did not finish high school and they are employed, 38%. For those who finished high school and are employed, 54%. Those who have some college and are employed, 64%. And those with a bachelor's degree and they are employed, 73%. Any questions? Let's take a look at non-employed. It doesn't appear to be across education level a big difference from all education levels, per education level. So the probability is that the more educated you are, the chances are that you will be among the 73% of the total of who obtained a bachelor's degree. If you obtain a bachelor's degree, you can be unemployed, but very little risk, very little, versus this. Not in the labor force. For whatever reason, they're not looking for a job, or maybe they're retired. I'm not sure what that particularly means. But for each education level, as you see, chances are higher that to be employed. If you have the higher education level, the higher chances you have to be employed. Any questions before we move on to the last part? Now, using the result, and this is interesting, using the results of part G, exactly what we have here. Draw a bar graph that represents the conditional distribution of employment status by level of education. So that is an interesting bar graph. So let's take a look at it. So these are the categories. So this is the level of education. And we are looking at 4 different categories. So this is did not finish high school. This is finished high school. I'm trying to make them equal in width. Some college and a bachelor's degree. Okay, so what do we know about the employed? Employed, about 40%. So what is the highest? I'm looking at all of them. The highest is 0.7. So I will go till 0.8. So 2, 4, 6, 8. 0.8, 0.2, 0.4, and 0.6. Okay, so let me use 3 different colors. One for did not finish high school, and one for high school, and one for some college, and one for bachelor's. It depends on employed, unemployed, and not in labor force. Okay. So let me use green. Okay. So I'm going to start with did not finish high school. So for employed. The employed is 37%. So I'm going to go this high. And then did not finish high school, and they're unemployed. That's very small. And 50% is not in the labor force. So again, this is employed. This is not employed. And this is not in the labor force. Okay, moving on to high school. High school, employed, 53%, has to be higher. then unemployed, tiny. And then the last one, 58%. Point 4.42, 42%. 42 right here. So again, this is employed, this is not employed, and this is not in the labor force. Okay. Moving on to high school, 63%. Same thing, not employed, same height, and then 0.32, so 32%. Again, so this is employed, not employed, and not in the labor force. Finally, BA, let's move on, 72%. Same, lower actually, lower than 0.04, it's 0.02, and this is 24%. 24%. So employed, not employed, not in the labor force. And we can see even from the bar graph that this stands at 70, what was it, 73% almost, 73%, much higher than all of them. The higher the education level, we can see the higher the percentage of being employed. The higher the education level, we can see even that non-employed goes down. And not in the labor force, I'm not really sure what to say about that. What does it mean per se? The problem doesn't really explain what not in the labor force. They can work, but they don't want to. They have some issues. They're not looking for a job, or they are self-employed. They're not in the labor force, but they have a job. They are happy with their job. They created their own source of income. So this is all I had to say about these two-way tables or contingency tables. We can, of course, we can analyze the columns as well and say, okay, employed, what happens across education levels and vice versa. I think they give us a lot of insight. A lot of calculations are required in order to be able to read what I'm looking for. These are so-called conditional probabilities. There is a theorem, it's called Bayes' theorem, which my colleagues decided not to present it in this class, but I think it's a very interesting, and it deals with conditional probabilities. This is a conditional probability. Why? Find the probability that it's employed, knowing that it completed some college, given. So knowing or given that we are looking at a particular category. So that's all I wanted to say about this, and hopefully we can go back and do some problems on that. But before, I would like to just show you the chi-square test. Chi-square test for association between a row and a column variable. That's why these two are paired. Section 4.4 and this. We are continuing with the same type of table, contingency table. So this is 12.2. When we are looking at, this is the notation for chi-squared. Chi-square test. Chi-square test of independence. What does it mean? What are we trying to do here? We're trying to say the same, the alternative and the null hypothesis. We're trying this time to see whether there is an association, there is a relationship between two variables, the column and the row variable, if they are independent or not. So the null hypothesis will be exactly, they are independent. They are independent. In other words, no difference. If this is better for you to remember it, no difference. Or no relationship better, not difference, no relationship. No relationship, no association. Here, they are dependent. They are dependent. There is a relationship. There is a relationship between the two. Okay, so let's see how we conduct this test. Everything is the same. The p-value is the same. The test is different, of course, but we are looking for exactly the same answer. What are the options? If the p-value is greater than alpha, we will say they are independent. There is sufficient evidence to fail to reject. Fail to reject. Or there is insufficient evidence to reject, whichever you want to write it. And the other option is when the p-value is less than alpha, we reject the null hypothesis, meaning they don't appear to be independent. They appear to have some sort of dependency. So in other words, what we just did are these categories, the column categories, are they related to the employment status? If we get that the p-value is less than alpha, we will say, yeah, they are related. It appears that they are not independent. But if we get, from conducting the chi-square test, and we get the p-value greater than alpha, we will say we fail to reject. There is no relationship. There is no relationship between this variable and this variable. Okay, so